Hi there! Now, let us try to divide these two functions. We have f of x is equal to x cubed minus 4x squared plus 5, and our g of x being x plus 3. Let's have our f of x be our dividend and our g of x be our divisor. Now, we also did division of polynomials or functions last time, but we're able to use the factoring method to that. Is easy to factor, but for this case, since the highest degree of our dividend is 3, and for similar cases, we can have another method for that. In this case, we are going to use here the synthetic division. This synthetic division allows us to use the coefficients of our dividend and a certain c coefficient of our divisor and a certain process that would involve solving for the quotient and possibly the remainder. To start, let us try to use the coefficients of our f of x. Okay, the coefficients of our f of x, we have 1 x cubed, that's 1. We have minus 4 x squared, and you have here plus 5. But this function of ours is an incomplete function since there is no coefficient for, or there's no term for x. That would mean we can assume that there is a term x there, but the coefficient is 0. It's very important to complete coefficients, especially in our synthetic division, as we are going to examine here the right processes, because if you are going to miss writing that 0 there, your answer would be incorrect. Again, it won't matter because if we have 0 and x, 0x is just 0. So in short, you're not adding anything. You're just simply representing that missing term by a coefficient of 0. And this is where we are going to place here the last coefficient of 5. If ever the x squared is not around, so it would be placed on the x squared placement. Now, this is for the first condition. The second condition is we are going to use a certain c that will be placed in this box here. That certain c patterns on our divisor, as we have here x minus c. But our divisor is x plus 3, not x minus 3. This would mean it is incorrect to use 3 here as our c. We should be able to construct our divisor in a form of x minus c. Take note that you can write this or rewrite as x minus negative 3. As you apply the double negative property, hence you will get x plus 3. This would mean, patterning to this, you have x minus c. Your c here is not 3, but rather, and more importantly, negative 3. That's you are going to place in this box here. Now, the two conditions have been met. Let us now try to start with the actual process of synthetic division. First step is for you to bring down the first coefficient, 1 here. This coefficient now will be multiplied to your c. 1 times negative 3 is negative 3. Then after that, you're going to add the coefficients here. So negative 4 plus negative 3, you will have negative 7 here. The next thing is to repeat the process. Negative 7 times negative 3, that's positive 21. 0 plus 21, you will have a result of 21. And again, for the final phase, 21 times negative 3, you will have here negative 63. Again, 21 times 3, that's 63, so negative. And then you will add this, you will have negative 58. Let us check. 21 times negative 3 is negative 63, that's correct. And then plus 5, negative 58. This final or last coefficient is your remainder. Okay, that's your remainder. These three coefficients here are the coefficients of your quotient. But take note that this one here is no longer the coefficient of x cubed. Okay? As we divide, we are going to have n minus 1 degree. That would mean our quotient, since our dividend is x cubed, our quotient is n minus 1 x squared, not x cubed. So 1, so you have 1x squared. Then you have your minus 7 here, Yung minus 7, that's the coefficient of your x. And then the final here, aside from negative 58, that's your constant, positive 21. So this is your quotient when you divide the two functions. But we are not yet done, as we have remainder here. We also need to express our remainder as part of our answer. Take a look at this. When you divide 3 by 2, okay, you can have this process here. Of course, you will have 3, you have 2. 3 divided by 2, 1. That's your quotient. 1 times 2, 2. 3 minus 2, 1 here. This is your remainder. Again, this is your quotient. This is your remainder. And this can be written actually as 1 and 1/2, right? This one here corresponds to your quotient. The other one corresponds to your remainder. And 2 is your divisor. In short, it is structured in this manner. The quotient of 1 and plus your remainder here to be divided by your divisor. Why plus? Because 1 and 1/2 can also be written as 1 plus 1/2. 1 being your quotient, and this is your structure here. So coming back here, this is our quotient earlier. Quotient, x squared minus 7x plus 21, that's your quotient. Now for this portion here, your remainder. Since your remainder is negative 58, let's use here minus. Okay, you will have here 58. Or for some of us who would like to make this plus, and since you will have here minus 58, so you're just going to change this as well to minus. Okay, so instead just simply write like this: minus 58 over your divisor, which is x plus 3. This is now your final and more complete answer as you divide the f of x and given g of x. And we use here the synthetic division instead of the long division. That's all for today. You're dismissed. And please do not forget to subscribe now.